Hello and welcome to the final video on graphs of Pure 1, where we're going to look at reciprocal graphs with x squared. So it's just a bit of an extension from the previous video with reciprocals where it was 1 over x. So here's the page from the workbook. So let me just get the... Okay, so again, we're going to use the same skills as we have in the previous few pages of videos, and it's just going to be an extension of that. Now, the reciprocal graph with x squared is, if you sort of think about it, it's not too much of a jump from the reciprocal graph 1 over x. So if you've got 1 over x squared, then why does the graph look like this? Well, if you think about it, any x value, you square it and then you do the number divided by that. If in the previous video when I looked at just 1 over x, there was a section of the graph here in this quadrant, negative quadrant. But when you square a negative number and you do a positive number divided by a positive number, then you'll get that quadrant, that section of the graph here will actually flip and go into that positive y quadrant. So the reciprocal with x squared graph either looks like this if a is positive, because it's a positive number divided by a positive number, or it will look like this if a is negative, because it will be negative divided by a positive. The denominator will always be positive in value if you for negative x values. Okay, so it will either look like this or this, positive, negative. So let's just think about the skills from previous videos and apply them here. So the first one, we've got 1 over x squared plus 2. Now, if you think about this, 1 over x squared plus 2, if you remember the previous video, when you add a number to an equation 1 over x squared, or the graph, then basically the y values will increase up by 2 on the y-axis. Okay, so if I had 1 over x squared, if I put in x equals 1, I would have 1 over 1, which is 1. But as soon as I add the 2, now I'm going to have a y value of 3. So it's going to look like this. It's a positive reciprocal with x squared, except everything will move up by 2. So it's not very symmetrical. And you've got to make sure that your graph is symmetrical as much as possible. Sketching these sorts of graphs. Let's make it easier for me to do this side actually. Yep. Okay, so there's my reciprocal 1 over x squared. Okay, and remember it's been shifted up by 2. And if you think about it, originally the asymptote was the x-axis, which has an equation y equals 0, but as we move the graph up by 2, that asymptote will no longer be there. It will be at y equals 2. Okay, and the other asymptote will still remain the same, which is the y-axis, which has an equation x equals 0. As always. Right, next one, we've got minus 3 over x squared. Now this is not too difficult. It's just going to look like this. Okay, so it's going to be very similar to this because a is a negative number. Okay, and a in this case is minus 3. Okay, so we're going to just got to be very careful with our sketch here. Okay, and the asymptotes will just be y equals 0 and x equals 0. Right, not a massive problem for part B. Now, coming up to part C and part D, things are going to get a bit more difficult, but we can handle that. So, we've got 1 over 4 minus x squared and 5 plus. So just draw the x and y axis. So 4 minus x squared is at the denominator instead of x squared. We've got to think really carefully about this. I'm just going to expand the brackets. So 4 minus x squared and if I expand the brackets, I'm going to get x squared minus 8x plus 16. Okay, so that tells me that it's going to be 1 over x squared. Ignore the minus 8 and 16 for the time being. It's going to be a positive reciprocal. Okay, so it's going to have this sort of nature. Okay, now the issue will be what will the graph look like after that. So what we have to think about with this is there any way where we can find an asymptote or an x value for which this equation doesn't work. So what I ideally want is an x value that I can put into this where the denominator becomes 0. If you look carefully, 4 minus x squared, if I put in x equals 4, that denominator will become 0 and it won't work. The equation will not work. So x equals 4 is my asymptote. Okay, and everything around that will remain the same. So the graph will still have its behavior around that asymptote. Okay, should be a bit straighter here, but that's fine. Now obviously it cuts the y-axis at a certain point. To find out where any graph cuts the y-axis, you put in x equals 0 and you get 1 over 16. So it's going to cut out 1 over 16 here. Okay, so this particular example is a bit more trickier, but again, sometimes you've got to look out and think, okay, if I can find the asymptote, everything else will be alright because I can put in any other x value apart from 4. And obviously the last one is D, and with D we're still using the same graph as above, as to the left, sorry. So we're still using 1 over 4 minus x squared. So we're going to use that, and we're adding 5 to it. Now if you remember, adding 5, the y values will go up by 5. So let's just also add one thing here. The asymptote horizontally is still y equals 0. Okay, so for part C that's the case, and obviously when you add 5 to the whole graph, when you translate it up by 5, that horizontal asymptote will no longer be y equals 0, it will be y equals 5. Okay, and the x, this vertical asymptote, will remain the same. It will still be x equals 4. Okay, and the graph will remain the same in terms of its behaviour around that asymptote. Okay, and obviously let's try and find the Y-intercept. So I'm going to put in 0 again. Obviously when you put in 0, you're going to get 5 plus 1 over 16. And if you were to think about how you're going to write that as a fraction, then you obviously got to add 5 and 1 over 16 together. If you were to convert that into a fraction, 8 over 16 plus 1 over 16, 81 over 16. It's going to be that. Okay, so this is the final video where we looked at all the types of graphs, and this deals with reciprocals with x squared. Okay, and you just start from the base types of graphs and think about your asymptotes and any intersects with the x or y axes. The practice questions are down here below. Well worth having a go. Good luck.